Once we have a good, filtered, clean fuel pressure, we take this low pressure, 3 psi, and feed it into our high pressure fuel injection pump. A lot to talk about here, so let's get down to it. We got two ways to control fuel pressure. First, the pump is located midway up there. It says the high pressure fuel injection pump itself. It's a circle with the arrow in it. Coming in from the low pressure, we have an internal transfer pump. This ITP transfers pressure, raises it above the 3 psi, and feeds it into the high pressure fuel pump and part of it around for lubrication. Going to the high pressure pump, between the internal transfer pump and the high pressure pump, is a volume control valve. It's duty cycle controlled. It's going to restrict how much fuel enters the pumping chambers. So our first control is a rough control, kind of a rough check to try to get us the fuel pressure we need in the output. But after we leave the pump, we're going to go further and do some additional. We're going to go to a pressure control valve shown over here in the front of the pump. It's a bypass valve that when we reach the pressure that the PCM has decided is needed, it will open up and start bypassing back to the fuel system the excess fuel coming in, so we maintain fuel pressure. So we regulate first pass the volume control valve, the fuel between the internal transfer pump and the high pressure pump. Then after we get the high pressure up, if there's any excess pressure, we release it with the pressure control valve with a duty cycle. Now, neither of these are separately available. They have to be bought as part of the pump. It's all as one unit. So now that we've gone out of fuel, we're going to route it to each of the cylinder heads and turn to there. But there's our pressure control valve, routing it back. So if we get too much pressure, we route it back and control it. Once we get pressure in there, the high pressure injection pump has a check valve. It doesn't come back, so we keep the rails full. So we got the left bank and right bank rails leaving here. Here's the actual pump. It's gear driven off the camshaft and turns at the same RPM as the crankshaft. It's a smaller gear, so it turns faster than the cam. It pressurizes the fuel and routes it to the two high pressure fuel rails. You can see here it looks just like we're working on a high pressure oil pump, the exception being we're looking on a high pressure fuel pump here. It's driven off the same size gear as the crank, so they run at the same speed. The cam in the middle runs at half speed of both of these. Here's our pump, which we look back on an engine we're tearing down and getting to work on. You can see it in the back there. Once we leave here, we're going to go out to our individual rails, which are going to hook to our injectors. And we're going to talk about our injectors later. But for right now, we're going to talk about the missing piece. We've talked about our fuel pressure varying between 3,100 psi and 29,000. The PCM is going to determine from operating conditions the desired fuel pressure. Here we're showing with this yellow line our fuel rail pressure sensor. We're going to read the actual fuel rail pressure. If that differs from our desired fuel pressure, the PCM is going to go back and modify the controls on the pump to either bypass it or restrict the intake to bring it in the target value. So what this is part of the closed loop system. We're going to measure the fuel rail pressure. After the PCM is set the fuel pump to give us the desired pressure. If it doesn't match, it will go back and make adjustments to desired pressure. So this is a feedback system, and it was going to handle that. Again, you'll notice we got good metal pipe, steel pipe systems. So this is going to be a closed loop system. Here's our injectors, and we're going to be talking about the injectors when we finish this and talk about what's special about these piezoelectric injectors.